Hi everyone, and welcome to a special edition of West Explains Best. We're going to the mailbag today. We have a request for number 10. Number 10 is a problem dealing with area, so let's go ahead and read the prompt. Find the area of each regular polygon, round your answer to the nearest tenth. Okay, so here we have a triangle and it tells us it's regular. So if it's a regular triangle, we know it's an equilateral triangle. That means this is 10, this is 10 kilometers, and we're asked to find the area. Well, the first thing we need to understand is the area formula for a triangle is 1/2 the base times the height. The base and the height for a triangle need to be perpendicular to each other. So if we go ahead and draw such a situation, okay, we have something like this, and we create this to be 90 degrees. So this would be our height, h. And that would make this line here, let's draw it, that would be our base. So our base and our height are perpendicular to each other. Now we have the base length, that would be 10. Our base would be 10. So we have that component for our formula, but we're missing the height. So how do we find the height? Well, since this is a problem on the section of trigonometry and area, you might have guessed that we're supposed to use some trigonometry here. Now, in order to use trigonometry, we have to have a right triangle. So I can go ahead and highlight such a triangle here. Okay, so such a triangle would look like this. There's also an identical one on the opposite side, but it doesn't really matter. We just need one of these triangles. So I'm going to grab this guy, make them like this, and voila, we have ourselves a right triangle. Now, what are the dimensions of this triangle? Well, we're looking for the height. That's the important thing that we're looking for. We want to know this distance right here. Okay, that's what we want to find out. We know that this distance here, the hypotenuse, is 10. Since it's an equilateral triangle, each side is 10, and that's one of the sides of our big equilateral triangle. Now, what is our base? Well, this particular base, this is not the same as the whole distance of the big base of the equilateral triangle. Now we're only considering the right triangle, so this is half our base. So this is only 5 kilometers. Let's write the units for this one. So we have 10 kilometers here, and that's 5 kilometers. So there's actually a couple different ways we can do the height. We could use the Pythagorean Theorem, or we could use trigonometry. It's really up to you guys. I'll show you both real quick. So the first way, the easier way, would probably be using the Pythagorean Theorem. The Pythagorean Theorem states a squared plus b squared equals c squared. Well, c squared is always a hypotenuse. So in this case, our hypotenuse is 10, and we'd square that. It doesn't matter which one we call b, so I'll just make my base my b. So I call that squared. And then our height is the unknown, squared. Okay, and then we're going to set this all equal to each other, plus and then equal. So I get, I'm going to change to blue here, so we get h squared plus 25 equals 100. Then I subtract 25 from both sides, and I get 75 equals h squared. Since we're dealing with decimals nearest tenth, I'm going to take the square root, and I will get a decimal here, which is h equals 8.66. But we're rounding to the nearest tenth, so I'm going to call this 8.7. Too big. 8.7. Okay, so that's one way to find the height. Another way to find the height would be to use trigonometry. Let me show you how that would work. Well, since this is an equilateral triangle, what we know in all these polygons, if they're regular, that means all the angles are equal. So if this would be 60 degrees, this complete one would be 60 degrees. And this one would be 60 degrees, okay? So if I transfer one of the known angles over here, 60 degrees, we have this one equal 90 degrees. So since the sum of all the angles need to add up to 180, we can subtract this missing angle here. We'll call it Z for now, or we could call it theta. I think theta would be, usually that's used for angles, so we'll call it theta, plus theta equals 180. So then we subtract, from 180, we subtract this sum, 150, plus theta equals 180, we get minus 150, we get theta equals 30 degrees. Now, we don't even need to find this angle really, but I'm just showing you if you want to use trigonometry, sometimes having the angles helps. But we can go ahead and just use this angle here, this 60 degrees, okay? Now, when we're using trigonometry, what we can do is, oops, sorry, let me not erase that. What we can do, well, what we need to do is we need to label the sides. So if we want to make this our reference angle, this is our reference angle, very important, okay? This is going to be our reference angle. We need to label the sides. So this is the hypotenuse, this would be the opposite side, and this would be the adjacent side. And we have our choice here of which trigonometric identity we can use. We can use sine, we can use cosine, or we could use tangent. But I'm just going to go ahead and use, actually we can't use cosine, but we want to use a trig identity that includes the opposite side. So what's the trig identity that uses the opposite side? That is sine. Sine uses the opposite sign, and so does tangent, but we can just go ahead and use sine. So sine is equal to, the sine of an angle is equal to the opposite over the hypotenuse. Okay, so we know the opposite side, well we don't, but we want to find it, is equal to h. We know the hypotenuse is 10. And we know our angle that we're choosing, this is our reference angle, this is different than what we did up here. Okay, up here I'm just showing that you can find the third angle if you want to use that angle for trigonometry. But we can just choose the 60 angle, so we're going to say sine 60 equals h over 10. What I like to do is I always like to put this over 1 and then solve. In this case, it's and then cross multiply. So I put sine over 60 over 1 equals h over 10. This makes it easy because now I can just cross multiply to get my answer. So I get h times 1 gives me h. I should write that in green, shouldn't I? Equals, and then I'll do this one in blue. We get sine of 60 times 10, so we can just go type sine 60 on a calculator times 10, and that gives us 8.66. So we get h equals 8.66, round to the nearest tenth, we get 8.7. So we got the same thing using trigonometry or Pythagorean theorem. So sorry that took a little bit. I just wanted to make sure to let you guys know how you can use trigonometry, but we're ready to plug in. Remember, our base is 10. We're not using this base here. That was only for that right triangle. So we get area equals 1/2 our base, which is 10, times our height, which we found to be 8.7. Whoops. And we're ready to multiply. So really we can just do 5 times 8.7. Just type this in on your calculator. We get 8.7 times 5, because 1/2 times 10 is 5. And we get our area is equal to 43.5 kilometers, don't forget the units, squared. And that's our answer. Another shortcut, one last way to do it for all our viewers out there that are looking for the shortest way possible. There is a formula for the area of a equilateral triangle, and that is side squared square root of 3 over 4, where s is the side length. So we could just type in 10 here for our side length. So 10 squared square root of 3 divided by 4. So that's going to be 100 square root of 3 over 4. That's the same thing as 25 times the radical 3. And if you type this on your calculator, you get the same thing. You get 43 point, well actually it might be a little bit different rounded. So let me go ahead and see what that is. 3 square root and times 25. And I get 43, I actually get a little bit different answer. I get 43.3, just because we're doing a little bit more rounding with the other method. So we get kilometers squared, but you get roughly the same answer. Okay, but I just wanted to show another way to do it. This way is the fastest way for all those viewers out there that are interested in that. So I wanted to show you the trigonometric function way. I wanted to show you Pythagorean theorem, and then also we have the quickest formula for area of equilateral triangle. That bell was our time limit, so that's all we have time for today. Hope you enjoyed this video. Thanks for watching. Be sure to send in more questions if you have them.